So after completing the analysis, you will get this data. So this will be the CV curve, and the data at, for example here, 100 milliwatt per second, 80 milliwatt per second, 60 milliwatt per second, and so on. Let's take 80 milliwatt per second as example. So it will show you the CV curve like this. Then you can click here at show data grid, and you will be given this data. So select scan number 2. So it can be easily going down, or you can divide going down, select from 0, and then find in the middle of the data. There will be another 0 here. So you need to click shift, and then on the mouse is the right click. So then it will only selected cycle number 2. Then you click copy, go to the origin. It is best to use origin software and paste it here, or you can click Ctrl V. So this is the data of CV curve at 80 watt per second. So there is 2 important value here. The first one at column B, the potential, and the second one is the current density. Or also you can use potential. So both is suitable for the calculation. But if you use current density, it will make your work is more easier, since we already dividing the current with the mass. Remember, you already putting the mass on the beginning of the analysis. In here we put the mass, then it will automatically calculated by dividing the current. So change here. Here you can see A is the x-axis, B is y-axis. Change by doing the right click, set as X, and then click Ctrl and select G. Press Ctrl and select G. Right? So we are selecting these 2 and click here line. So it will replot your CV curve. You need to do it individually for each scan rate. So by using the analysis, go to calculus and then integrate. So it will integrate your CV curve, and here is the valuable data for the next calculation. Then you can copy this one, and then the data will be used for this equation. So this one already been discussed in class. So the area data will be the integration of IEDE. 2 is the dividing factor by the charging and discharging of CV curve. M is the mass. Since this one already consists of I over mass, so you can neglect or just put 1 for the mass. V is the potential. So we are doing this from 0 to 1.2. So the open potential will be 1.2, and here is the scan rate. So in this case, we are using 80 watt per second. So you need to calculate the specific capacitance at specific scan rate.